Hello everyone. In this project I want to explain how to use R-trig, F-trig and linear transformation by ST programming. In this project Codesys is connected to Factory IO by KepServerEX to be able to simulate the code. The goal in this project is to calculate the object length on the conveyor by using a diffuse sensor. We can set the conveyor belt speed and the output is object or box size. Okay, let's start the project from scratch. First, create a new standard project. Start programming in PLC PRG organization unit. I apply FIO in start of the tags that I want to use them by Factory IO. And in Factory IO, you will see that it is easier to find these tags. To find the rising edge of the diffuse sensor output, I define R-trig 01, click on F2 button, and in text search write R-trig. I do the same for falling edge and using F-trig. Enable count activates when the diffuse sensor detects the object. I use billing function to produce periodic signal and then count the time cycles. If you cannot find blink, you have to add the library util. Click on F2 button, find R-trig 01 that finds the rising edge of the diffuse sensor, and if the output of it is true, it enables counting. Blink 01 will be activated by enable count. The smaller value of time low and time high in blink function, the more accurate will be the result in calculating the length. R-trig 02 is for finding the rise edge of the time cycle, and when it is true, it shows that one cycle is passed and we can add the value of the counter of the cycles. And I define count pulse variable tag for it. Next tag is F-trig 01 for falling edge of the sensor to disable the counting. Length of the object is equal to number of cycles multiply the cycle time multiply by belt speed in meter per second, and finally multiply by 100 to obtain the length in centimeter. Define belt speed and length as real variables. Another thing is that we have to reset the cycle counter by rising edge of the sensor output. The last step is scaling the belt speed by linear transformation function. The range of the input is 0 to 3 meter per second and the output range is between 0 to 10 volts. FIO analog output belt speed is the output variable. Now compile the program and there is not any error as you can see. To be able to have access to necessary variables in Factory IO, we have to create symbol configuration. First build it and then select the necessary variables. In next step, we need to create a visualization page to enter the build speed and monitor the length of the box. In text field, by using %i, it refers to an integer value, and %f refers to real value. For box size, I used %4.2f. That means that the value is real with 2 decimal places. For the text field, we have to do the input configuration and inserting the text variable. Okay, now compile the project. For better understanding of the code, I try to explain it in comments. I realized that I wrote the lens word wrongly and I want to modify it in whole the program. To be able to go to online mode, we have to run Ctrl Win V3, then scan the network to find the PLC, but in this case your computer works as PLC. After connecting, download the program and run the PLC. In next step, run KepServerEX, click on new project and add new channel, and select Codesys as the type of the channel and click on next to finish. Now right click on channel and select device discovery. Begin discovery and wait to find the device. Okay, now go to tag import and it shows the variables that we have selected before in symbol configuration, and transfer them to right panel and click on OK. Now open Factory IO and create new project. Drag a 6-meter conveyor from toolbox and then an emitter and remover. By forcing the belt conveyor and click on run, we can see what happens. Now we need to insert a diffuse sensor in middle of the conveyor. Here I deselect any base to emit. Now the project is ready and I release the conveyor. Go to the file and select driver. Here we select OPC client and then go to configuration. Select KepServerEX. Filter the names that contains FIO and then browse. Come back to driver and you can see the server with two variables. Connect diffuse sensor to server. The conveyor is in digital mode and we have to change it to analog to be able to change the speed. To have a better calculation, I changed the cycle time to 100 milliseconds, so time low and time high are 50 milliseconds. Here I have to explain that the maximum belt speed in analog mode is 3 meters per second, so I have to modify the program and the input range is 0 to 3. I changed the belt speed field to %1.1f to be able to insert decimal number. Okay, download the program. Insert 0.2 meter per second for belt speed and you can see the results. I have to explain that this video was just an example to learn how to work with Codesys functions in ST programming, and for sure there are other ways for calculating the length. This way is a good approximation but is not very precise. If you decrease the cycle time when you are working with real PLC, the measurement is really better. As you can see in the simulation for belt speed 0.2, there is about 2 cm measurement error. In this way, always there is an error proportional to one cycle time of billing function and the belt speed. Thank you for watching this video. I hope that you enjoyed, and please like this video and subscribe the channel. Have a good time.